up the classwork on this today, and it is really more about algebra than anything. Don't be intimidated. It feels like it's a little worse when you're doing these problems, but if you just in your head think to yourself, it's just substitution. It's solving a system with substitution. As ugly as the numbers look, I know you're used to solving systems that look like 2x plus 3y equals 5. And this time your systems are going to be these nasty looking parametric equations. But ultimately, you're just plugging stuff in and solving a system. So if you keep that in mind and just carefully go about your business and stick to the algebra you know, I think that you'll, or that I'll remind you about today, because you are going to use some of the things you learned about parabolas to make your life easier. I think you'll be in good shape for this test. Nothing really shocking or new shows up on this particular test. All right, so I'm going to throw you a little bit of a curveball compared to what we did yesterday. If you remember yesterday, basically I gave you a problem where you had all the information. I gave you everything you needed, the initial velocity, the initial height, the angle that it was released, whatever, and you plugged it into your equations. And then I asked you a particular question. And the question I asked you, I gave you some information. I actually told you where this projectile, not where, I told you the height of this projectile or what it needed to be at the end. So I gave you the y value, but you didn't know the x and the t. So if you're given the y value and you don't know the x and the t, we say, well, you could just plug that y value in. Because remember, the y doesn't stand, the y stands for the height any particular place in time. That h is just the initial height. So I plugged that 10 in there, and then when I moved it over, you basically had a quadratic equation. And hopefully you know that anytime you have a quadratic, where you have like a t and a t squared, or even just a t squared, that you can solve using the quadratic formula. Don't try factoring these, okay? So we did that. We used the quadratic formula. We talked yesterday about how it might make your life a little easy. Everybody with me? Might make your life, everybody with me? It might make your life a little easy, like if you saved the b value as a b, because you could just put it in there. It makes it a little bit easier in terms of entering in those values and for a, b, and c and solving. And then we also talked about how these two equations, the x equation, the y equation, are basically, we have separated a parabola, basically separated this parabola with a time component. And the time it takes to get to a certain height is the same time it took to go that far. So if I can solve the t like I did here for the height equation, then I can use that same t in the horizontal length equation to find out how far it went. Because that t is a shared t, okay? Because it goes with that single point. Well, keep that in mind for this, because the next equation I give you, I am not going to give you all the information for the initial parametric equations. But what I will give you is a little bit of extra information. And I want to see if you can know what to do with it. So here we go. While standing at home plate, Mr. Hurry throws a baseball towards the right field fence that is 310 feet away from home plate. The ball hits the right field fence 3 feet up the fence. The ball left his hand at a height of 7 feet when he threw it. The initial path of the ball formed a 45-degree angle with the ground. From this information, answer the following questions. Now, you in baseball are probably like, man, you can't do that. But there's no friction in this problem, right? So you'll find by the time we get to the end, all you got to be able to do is throw it about 67, 68 miles an hour, which is not that overwhelming. And if you can do that, if there was no air friction, then that would actually happen. But we know we're in the South. There's a lot of friction, a lot of thick air. That would take quite a gun to sit there from home plate, hit the left field, right field fence. But anyway, what do you know right now? Fill in everything you know about these parametric equations. So what do I need for the x? Like in those equations, talk to me now. What do I need? Initial velocity, do I have it? Okay, that's a problem, but I'm going to put VO in for now. Then I need what?
The
Cosine of the angle. I probably shouldn't have used 45, because with 45, you're tempted to go ahead and say, oh, cosine of 45, that's root 2 over 2. Pretend it's 43 or 41 or whatever, because you're not going to get a nice unit circle value on your test. It's going to be something that requires a calculator. So I'm just going to leave cosine of 45 in there. And then what? times t. Don't forget the t, because that's your variable in there that's changing x for each unit of time. Okay, now what do I know about the y equation? Okay, so the initial height, I threw it from an initial height of 7 feet. So there's the 7. Then plus initial velocity again times the sine of 45 degrees times time. And that's a big thing people forget a lot. On this test, people walk up to me like, Mr. Hurd, man, my graphs are not working. And I look at their equations and I'm like, you're missing something. And that's all I'm going to be able to tell you. But people forget to put that t in there. And then how do I finish it up? Because if I stop here, this is just like me doing what? What would this represent? This would be what? So this is me without gravity, right? So I haven't put the gravity component in there. This would never go down if I throw it. You just keep heading out in a certain direction. So the gravity component, we've already talked about that. We don't use negative 9.8 meters per second because we're going to do it in feet per second. So what did we use? Yeah, it's going to end up being negative 16 because it's really negative 32, but the formula from the calculus is a half of that. So it's always going to end up being negative 16 t squared. So those are my parametric equations, and unfortunately, I can't really use them. I can't really use them right now because I don't have initial velocity. Now, you remember on the last question, I gave you a situation that looked similar to this. Like we shot it from right here, and it basically said we were talking about a goalpost, and all I knew was it needs to be at a height of 10 feet. That's all I knew. But what do I know this time on my projectile? First of all, it's not a goalpost. It's just a fence I'm hitting, right? And I'm hitting it where? So I'm starting at a height of 7, and it's hitting at a height of about 3. But what else did they give me? Yeah, it told me that it was 310 feet away, and that I was 3 feet up. So of that coordinate, I know the 310 and the 3, but I still don't know the time it took. In fact, if you read down for C is asking you for that time it took to get there. Well, anybody got an idea? Now remember, all I'm trying to do is solve a system. So how could that help me? My y is definitely 3. And in the other question we had, I knew velocity, didn't I? So in the other question, I plugged a 10 in there, and the only variable left was a t. But this time I don't have v. But I can still plug a 3 in there, can I? So I'm going to plug a 3 in there for the y. And I look at this and I go, well, that's still trouble because I'm missing VO and t. So I can't directly solve this second. But what else do I know? I know 310 is the x, and I can plug 310 in for this. And even though I don't have it easy like I did on the last question, where all I had to do was solve for t, what do I have right now? I have a system of equations. Now, it's not pretty like I said, it's not going to be pretty like this, where x equals 2y plus 3. It's not pretty, but on any system, even if it doesn't line up pretty or maybe become an elimination problem, I know I can always solve using what? Substitution. Substitution is my go-to whenever it doesn't line up and look pretty. I mean, this to me does not feel very Gaussian-like. I'm not going to get that into a pretty matrix. I just am not. I mean, first of all, with Gaussian, we always had like X, Y, Z, things like that. We've got here a linear situation. Here we've got a quadratic situation. I'm kind of all over the place on this. So I'm just going to stick with substitution, which means you have a choice. You can either solve for V and plug that in, or you can solve for T and plug that in. And you can do it technically with either equation. Which equation do you think you want to start with? The first one or the second one? I think the first one is an excellent choice for many reasons. First of all, if I solve for V here, it's going to be awful looking, right? And then I'm going to take that awful and insert that awful there. And now I've got doubly awful. So I have no desire to mess with this one right now. But solving for this one doesn't look that bad. Okay, so now that we've decided we're going to solve for this one, and again, my goal is to get V, because once I get V, I'm kind of home free, right? I've got nice, neat parametric equations. So would you rather solve for VO or solve for T? And you can do it either way, but one way is better. You want to try T? Now, if I did time, I'm going to show you what it looks like. It's not bad. It's just going to be a little bit uglier. Let me show you. So if I want to solve for T right here, I would have to divide both sides by VO cosine of 45, right? So I get, tell me if you're with me, to solve for T, I'm going to divide both sides by VO cosine 45, which leaves me with 310 VO cosine 45. And I would have to take this and plug it in where? There and there. Now, again, this is not the end of the world. If I plug it in there, the nice thing is the VO that's already there cancels with that VO pretty nicely. But the problem, the only problem that makes it a little harder is not only do you have to plug it into two places, which is two substitutions, but when I plug it in there, now the very variable I'm looking for is in the denominator, which is, again, not the end of the world, but it makes it a little bit more tricky to solve for because I'm going to end up having to do all the math and then flip both sides. It's a little extra step. Now, if I solve for VO, what would you do? I would divide by cosine 45t. So cosine 45. So if I solve for VO, the nice thing about that is I only have to make one substitution, which is right there. So that part's a little bit better. And then also, once I plug it in there, look, the t on the bottom, and I'll show you the math, is still going to cancel with that t, which is great. And when I plug it in here, that's all I do is plug it in there, and then all my variables are now gone except this t squared, and I can simply solve for it. Now again, every year I have a few people that solve for t, and they're fine, but it is a little bit more algebra and a little bit more of a struggle. So I'm always going to solve for VO. Okay, now I know that this part B says, what is the initial velocity? So I know when I plug it in there, I don't have V in my equation anymore. So what I'm actually going to be doing is solving for time. But is that okay? I mean, if I solve for time, what could I then do with it? Plug it back in to get my velocity. And in the meantime, I've already answered number 3, which is what is the time? And I'm going to have to answer that question anyway. So here we go. This is me plugging it in right there. I get 3 equals 7 plus that. So carefully, I'm going to write 310 over cosine 45t times t. And remember, that t is not 45t. I'm not taking the cosine of all that. I'm doing the cosine of the 45 times the t. So when I plug that in there, remember, there's still a sine of 45 there. And there's still another t there. And then there's the minus 16 t squared. And what happens to the t on the top and the bottom? They are gone, which is great. And the only variable I have left is right here. So all you have to do at this point is take your calculator out and combine all this junk together and move it to the other side. Or just take 3 and go minus 7 minus 310 sine of 45 over cosine 45. And by the way, you could shorten that step by a little because you're always going to have a sine over a cosine. So it really ends up being a what? A tangent. So you could just do 310 of tangent of that angle. And in this case, I realize that the tangent of 45 is 1. So all that really just cancels. But again, you won't have that. Don't get it in your head, oh, those just cancel. Because that's only true if it's 45 degrees. And it won't be 45 degrees moving forward. So once I move all that stuff over, you tell me what you get. You get negative 16t squared on the right. And you get negative what on the left? Anyone? Negative 314. And then your last 2 steps are to divide by negative 16. Just going to cancel your negatives out and give you some number, and then you're going to square root that number to get your time. And your time technically is plus or minus, but we are not going back in time. So we're going to ignore that. So I get 19.625. And remember, guys, I don't mind you when you're showing me your algebra. I certainly don't mind you writing something like 19.6 or 19.625, but always use the exact value. Never round until the very bitter end never round and then reuse a rounded answer. You've got calculators. If you have any trouble going back and grabbing stuff and reusing it, let me show you how to do that with your Inspire or whatever you have. But make sure you're always exact. Now, even if I write this answer exact, even if I round that answer to say the hundredths place, when I reuse it back up in here to find velocity, use the exact value. Okay, we never want to round. And if you find an error on my key, let me know. So when I square root that 19.625, I get 4.43. So in 4.43 seconds, the ball has been thrown and it has hit the fence. And we're not calculating the time it takes to drop to the ground, whatever. I don't even know what that would be. All right. Would probably depend on how, whatever, elastic the fence is. Now, at that point, I've really answered part C. So that is how long it took to hit the fence right there. So we can call that's the answer to C. And so for the answer to B, what am I going to do with that? Plug it back in for T to solve for V. So my initial velocity, I'm going to set up a fraction. Everybody know how to do a fraction on your calculator? Okay, make sure you can do this. Remember, it's cosine of 45 times the T. Don't put the 45 and the T in the parentheses together. If it helps you to put the T out front, do that. So fraction button. And I've got 310 and cosine of 45 times my answer. So 98.96. For those of you who are like, man, you can't throw that fast. Remember, this is feet per second. So if you really were curious about the miles per hour, what do? Say it again. Do a little stoichiometry, right? So if this was feet per second, if you were curious, I would say, well, I know that 5,280 feet are in 1 mile. That will get rid of my feet. I know that there are 60 seconds in a minute or 3,600 seconds in an hour. So I could say 3,600 seconds in 1 hour to cancel out seconds. And now I have miles per hour. So I'm going to take that, multiply by 3,600, divide by 5,280. I'm going to take, forgot about it. Multiply by 3,600, divide by 5,280. I get 67.47. So if you can throw about 67, 68 miles an hour in a no friction environment, you too can play catch with the guy in deep right field from home plate.
Is it always going to be like in seconds?
Yes, because when I used it, well, only because you chose that by using negative 32 feet per second. So because I'm using that value right there, that is controlling for me. And by the way, I'm not going to throw you curveballs and give you velocity in miles per hour. So then you have to convert. I did that actually in my early years, and it was just kind of cruel. So I'm not going to, I don't think it's cruel for you to be able to do stoichiometry. Make sure you can do some stoichiometry, right? That's what? Basic chem? Did you learn that?
Yeah.
Okay, so make sure you can do a little stoichiometry. If you need help with that, let me know. I always loved stoichiometry, but whatever. Well, maybe not love, but I always thought it was kind of makes sense. Wasn't that bad? But I won't do that to you. So I will give you velocities in feet per second because we're using that unit right there. It came from feet per second squared. Are you with me? So yeah, so for the work we do, the time is always going to be in seconds. And when you measure velocity, it'll always come out in feet per second. And I don't need you to convert that unless I specifically say convert. And if I did, what I'd probably do is say, hey, if this was 98 feet per second, what would that be in miles per hour? And I might do something like that to check your stoichiometry. but it would not be worth a whole ton of points because that's not my main objective on this unit. Are y'all with me? So I've just answered part B and C, but more importantly, what did I get that's really useful for me? My initial velocity. So now that I have my initial velocity, which is 98.96, and by the way, I'm rounding 98.96 when I write that, aren't I? What would be a really good idea for you if you were going to use parametric equations and you didn't want a rounded value here? I would say you have two options. Store it as V, and then when you write out your equations, have V in there. And then you have 98.962773767 in there already. Or the other option is, and when you type that in there, just type in a lot of decimals. Because the more decimals you type in, the less of a chance of it mattering. So if I didn't want to store it, I would probably type in literally 98.962773767, both places, and I'm going to be fine. There's no way that's going to affect my decimal out here at 2 or 3 places, if I include that much. Y'all seeing that? Okay, now let's see if we can use our brains to figure out the rest of these questions. So I'm going to keep those velocities up here and erase the rest. I've already answered B and C. Let's check out D. So here are my equations. All the rest of this, we're going to erase the next. Now, what was the maximum height that the ball traveled? Now, in this course of travel, the maximum height obviously is at the top. Anybody got any ideas how to find that maximum height since you don't know calculus? Go to what?
Put your equation in the.
Do the what?
Like graph it in your calculator.
Oh no, well, good point. Yeah, and we will do that in a second with our calculator. If you don't have graphing capabilities, and I want you to show me the algebra of it. What do you know? I want you to just think. A lot of you guys are just waiting for somebody else to talk. But think for a second. What do you think we ought to do? What do you know about this situation and the maximum height? Just okay. So it is a parabola, and the maximum height would occur at the vertex. Now, it's a little bit different than that, although that's where I'm going, because most of the time when we deal with a parabola, I'm dealing with X and Y, right? Now, what is the parabola part of my parametric equations? It's that one, right? And that's not X and Y, that's what? That's T and Y. So this is giving me the time it takes to reach a height. So my vertex, again, not X and Y, it's the time it takes to get to that Y. But that's still good for me. Now tell me, and just throw something out, I don't care if you're wrong, don't worry about that. What do you think I need to do to get to that height, to find that vertex? You've learned a lot of ways to find the vertex of a parabola. You certainly can put it in parabolic form, which would require a little what? A little completing the square? How fun does that look on this problem?
Not fun.
Doesn't look that fun to me. Now, I could use my rules and complete the square. Is there anything else we learned? Yes, sir.
Find an x coordinate at y equals 7, like on the farther end, and then take the average of those at x. That length.
Could you find the x? So you're thinking about this graph.
Like scooted over 4 feet.
Right.
Okay, so instead of finding where it hit at a height of 3, you're saying where would it be at a height of 7?
Right.
And then
Okay, now I like that thinking, except that's a lot more work for you, right? Because you're going to have to now go in and say, all right, at a height of 7, that would be like the problem we did yesterday. And you wouldn't really be finding the x immediately, you'd be finding the time, right? Because if I plug 7 in there, I'd have to solve for time. But what he's saying, we're going to lead to that, what he's saying is, right now, the parabola is kind of unbalanced, right? So coming in from a high, I'm starting high. The total time, it was not the same amount of time to get up as it was to get down. But he's saying if I went to a height of 7, on the end, at the end, then it would be the same amount of time up and down. And you could take that total time and split it. And you could do that, but to me, having to plug 7 in there to find the time it took to get there and then half it seems like a lot of work. Let me ask you this question. Would that mentality be the same as finding where they both hit 0 and averaging that? Now, what does it mean when you solve a quadratic and you're finding out where they both hit 0? Those are the roots, right? And the roots just mean I'm solving the system, right? I'm basically saying when it hits 0, solve. What have I used forever to find the roots of a quadratic equation? The quadratic formula? Okay. And what were always my 2 answers that the quadratic formula spit out? What were they? Weren't they negative b plus and negative b minus? Isn't that what the 2 answers are?
Yeah.
So hypothetically, if this is the time it took to get to 0 going back in time, and this is the time it took to 0 going forward in time, if I knew those 2 times, what could I do to find the time in the middle? Average them? Now you're going to love how this ends up. Add them together and divide by 2. We're not going to do this math. We're going to just remember something, but I want you to see it. What do I get when I add that fraction to this fraction? What happens? What cancels? So first of all, everything ends up being over a 2a, right? Right? When you add them together. But then this part cancels. And what are you left with here? Negative 2b over 2a, which is negative b over a, divided by a 2. How do you divide by a 2? You multiply by the reciprocal. Does that ring a bell to you? Didn't you learn last year to find the x coordinate of a vertex, you could just do negative b over 2a? Right?
Yeah.
Well, it's not the x coordinate anymore. It's the what?
The T.
It's the t coordinate. So from here on out, if I ever want to know anything about the max, just use that to find the time it takes to get there, plug it back in to find the height. So literally, all I have to do here to find that is go, well, the time it takes to hit the highest part, but it's the same thinking that he was saying about find out the time it took to go from 7 to 7, but we're just using something easier. It's the time it takes to go from 0 to 0, which we already know, and it works every time, and we don't have to go through the pain and suffering of plugging 7 in. But the thinking's great, because you do, without friction and stuff like that, same time up as it's down if I'm going to the same heights. So with that, negative the b value, which is 98.96 sine of 45, over twice the a value. And the 2 negatives cancel, and we're just going to type that in our calculator. But remember, we're going to be exact, so I'm going to go back and grab the exact 98.96277736, multiply that by the sine of 45, and divide by the negative 32, and I get 2.1867, and that's seconds. And if I know that, then what was the maximum height? Plug it back in the y. So all I have to do now is find the y at 2.1867. And again, we're trying to show my math here. You have to show me that you understand the algebra. So if all you do is do this in your head or on your calculator and write an answer, I'm going to assume you graphed it and cheated, and didn't actually use your non-graphing capabilities. So show me. It takes a second or two, but just show me the 7 plus 98.96 sine 45 times t minus 16 t squared. And you're welcome to do, just say t and just draw an arrow to save yourself a little time if you really want to. If you want to do that. So I'm plugging all that in there, and that spits out whatever that spits out. 7 plus, I'm gonna go grab that 98.96 times the sine of 45. Are y'all comfortable with doing like second answer and all that kind of stuff? So tell me what you got if you're comfortable. Anyone? Just one person at least confirm this. And this would have to be feet because it's why it's a height. So you don't have to show me all the proof of why negative b over 2a works. I think last year we were doing completing the square, and I did completing the square to show you the negative b over 2a. But that's because when we were completing the square last year, we technically didn't know the quadratic formula, right? We were completing the square to learn the quadratic formula. But now we know it. So that's why I showed you the proof with the quadratic formula answers, how they average together to give you that x value, or in this case, t value that gives you the root. All right, now, using your graphing calculator. And we'll do this until the bell rings, and then any last questions you have, great. So I want you to go to your calculator. I'll pull this up for you so you can follow along with me. But go to your calculator and go to the graph mode. Okay, so you'll have this screen. And right now I'm still stuck on polar. And by the way, you will not need polar on your test because you're not going to be graphing anything in polar. You're going to do all that manually, right? So I'm going to go menu. And you remember, we normally like it to be in the graph entry. We like that to be in function mode. I'm going to hit 3 for graph entry. And I'm going to go down to parametric, which is 4. And when I do that, actually, you know what I want to do? I need to get all this junk out of here. Delete it all. Okay, so now that I'm in polar, when I hit tab, now that I'm in parametric, when I hit tab, this is what I see. And sure enough, I've got an x equation I can type in. I've got a y equation. But here's something troubling. It could be trouble. What does it say right here at the bottom? Now, you're seeing that 6.28, which is a leftover from the polar, right? Like 2 pi. But what this says is this calculator is going to stop graphing after 6.28 seconds. What if I shoot Biff the human cannonball from like here, and I'm trying to make him, send him to Auburn, right? He's going to be in the air a little longer than 6.28 seconds. But if all I allow is 6.28, then I'm going to see this, and Biff's going to be just suspended in air. And I'm never going to figure out when he crashed or landed in the lake or whatever. Okay? So, in the olden days, I had this crafty 84. And the 84 took a lot of time. So picking the right t value is important. Because if you left t at 100, you might be sitting there with a little dial at the top spinning. This thing might take literally 10 minutes to graph your equation because it was really slow. All right? But our calculator's fast. So I don't even think we have a problem where t gets over like 12 or 13, but it doesn't matter. Put it on 30. Your calculator's pretty quick. So I'm going to type in the equations I just had. Does anybody remember what they were?
Y equals 7 plus.
Okay, so first thing was, somebody tell me real quickly what that 98.96 was. Yeah, but give me the whole number. Can you just tell me everything you see on your calculator? 98.96.
98.9630258094.
Okay, so I'm just going to call that. I'm going to store it as V on this problem. Okay, so it is stored. I know you only see 98.963, but all of that is stored. So now, when I go to graph, check it out. I'm going to go to my graphs. When I go to graph this, all I have to do is hit V, and I have that exact value in there. Okay, so I'm going to hit V. You'll notice it looks dark because it's a saved value. By the way, don't ever save for X, Y, and T. It'll mess everything up on your test. To unsave, great question. To unsave, go to menu and go to number. Nope, go to menu and go to actions and clear A to Z. So if y'all all want to do that right now, unless you just stored V, but if you want to play it safe, and do that right now. It'll clear out all your storage, and then you don't have to worry about it. Because once you save it as V, it'll be that V value for all time until you oversave it or clear it. So I usually save everything with just common variables like A's, B's, V's, but I don't use T, X, and Y because those are variables that are constantly changing in these equations. So if you save T as 3, then when I type these equations in and I need a variable, it's not going to be a variable. It's going to be 3 every time. Is that making sense? Okay, so I'm going back and I'm going to go to my graph and I'm going to type this in. So V times the trig cosine of 45, go outside the parentheses, times little t. And then Y was 7 plus, oh man, I got rid of my V. V. Try it again. V times trig cosine 45 times t, and then 7 plus V times sine 45 times, and I like to put times t in there. You shouldn't have to, but sometimes it does actually matter, times t squared.
You have to be in degrees mode.
And I definitely have to be in degrees. If I want to graph this, I'm going to change my step. I know I see the word rad above, but remember radians is,
How do you get out of like?
oh, you know what I may have done? I hope I didn't. Hold on.
Did you go to?
I'm in my.
Here, I'm going to hit enter on this, and I'm not going to worry about the graph.
And then parabolic.
Here we go. I'm going to go to settings, and I am in radians, so I need to change that to degree. And you know what else?
Graph.
When I saved this, no, I'm good. I'm good. So let me ask you a question. Why can't I see anything? Because my window is pathetic. I mean, I threw this from a height of what? 7 feet? And it didn't even start. It's off this graph here. Now, I certainly don't need to see anything negative. Not that, or not that. So I'm going to go to my window, go to menu window, and I'm going to go to window settings, and I'm going to make my minimum X 0. Why not? I'm going to make my maximum X. Well, you do the math. How far do you think I could throw this thing? Now, we already know it's 310. What if you didn't know? What if I had no idea? I don't know. I'm just going to make it a cool 1,000. See what happens. Auto, scale. I don't care about the scale. That's putting tick marks on the bottom. Who cares? Y min. What do you want to make your Y min? Don't make it 7 or 3. I want to see the floor, right? So make that 0 as well, unless you're like throwing something off the top of a building and it's going to go below ground. In that case, maybe make the floor 0, make the top of your building 1,000 or whatever, but sometimes you may need to see lower. But then how high do you think it's going to go? Well, I already figured that out. Maximum height was what, 80 something? But pretend I don't know. 40. I'm doing weird things just so you'll see this picture. Now, what does that show you? This is my graph. It looks like it gets shot up and comes down. So right there, if I want to see a better window, what do I probably need to do? Adjust the window, so give myself more height. And also, if I want it to look real pretty, did I really need 1,000? I probably could have cut it to what? 500, maybe even 400, if you're looking at this. So let me just go back and adjust my window and make the settings go up. Like I didn't need 1,000, I'm going to make it 400. And let me make the Y max not 40, but how about 100? Let's see what happens then. That's a nice parabola. I can work with that. Are you with me? Now, look what happens if the time's messed up. If my time, for instance, only went for 3 seconds, and you go to graph it, Biff just blew up and vanished. And I'm never going to be able to figure out what happened to Biff down here because he vaporized because I only gave him a 3-second journey. So again, if you keep your time, your T step right here, not your step, but if you keep the time interval a little bit higher than 6.2, T1, X1. If you keep that one a little bit bigger than 3, just make it 15, 30, whatever. The calculator's pretty quick, you can see that. Hey. All right? Now, once I have this, how do I use this? Well, that's where the trace comes in. Now, I don't want to be sloppy on my trace. If you just go to menu and hit trace and do graph trace, all it does is put the cursor somewhere on the graph. Right now, it looks like I am what? What does it say right here? I am 297 feet out, 15 feet up, and I've been traveling for 4.24 seconds. And if I start scrolling left or right, you can see that. You see that? But it scrolls pretty slowly, doesn't it? So if I asked you a question like, and by the way, time is what you can enter to change this. It's not like a regular graph where you go trace and hit x equals 4 and it jumps to x equals 4. It's t that controls the behavior. So right here, if I wanted to know what happened at time 3, if I'm on trace, I can just enter 3. Notice you see it at the bottom? I enter a 3 right there and just hit enter. And it jumps to t equals 3. If I want to see where it is at 4, I enter 4. It jumps to where it is at 4. If I want to know how high it is in the very center, I go, well, it's not 4, it's not 3. Is it 2? I can get pretty close. Now, I don't want to just trace. I want to make sure I trace accurately. So I'm going to go back to trace right here at 5, and it gives me a trace step. So the trace step 3 allows me to control how accurate the steps are. Right now, I'm moving every 1,000th of a second. That's a lot of slow movement, isn't it? So every time I click my button, I'm like, I'm going to be here all day. So what I like to do sometimes is to change that to like 0.1. If I change it to 0.1, then look, I can move a lot more quickly. And like right now, I can get to the top. The only problem is I don't know how accurate I am because I'm only accurate to a 10th. I'm going to ask you to be accurate to the thousandths. So once I get close, I'm sorry?
Where's the trace thing?
I hit menu, trace, and then go to trace step 3. Okay? And again, I chose 0.1. So right there, I'm pretty close to the top. So I'm going to go back now that I've adjusted and gotten close and go menu, trace, trace step, and try 0.01. And I'm going to try to get even closer. Now, how can I tell if I'm as high as possible? What do these variables represent again? X movement, Y movement, time movement. Look at this one right here and tell me what's happening as I scroll left. 83.51, 83.512, 83.51239. Did I get, I'm looking at these values. Look, right there, I'm going to the right now. Like, I'm going to go one left. That value is smaller than that value. And that value is, what happened?
That's small.
So this looks like the biggest value. I'm literally scrolling back and picking the biggest one. But you need to be accurate. Menu, trace, trace step to the 0.001. So when you do that, get up there and scroll and see what's the biggest value. 5.128, 5.129, 5.13, 5.131, 5.1313. Oh, nope, 5.1313. That's the highest one. That is the highest value right there, and I'm just going back and forth until I find this biggest one. Is that making sense?
No, it doesn't show me that many decimal places.
Okay, if you don't see enough decimal places, then you have to go menu, settings, and then fix it at 5. Or at least 4, because we're going to be rounding to 3. Hey, we'll talk more about this tomorrow. See what you can do on the homework, and we'll tie up any loose ends tomorrow, and hopefully get in good shape.
I sit at the very front. I sit like right next to her.
Okay, don't worry.
Okay.
I wonder who it is. Who sits in the second row?
I give you this. Nashville.
Oh, yeah, man.
But just about.
That's the wrong one, yeah.
Yeah, I don't.
Oh. All right, man. So do you have to give these to all your teachers, or do you have to give them like 4 of them, or what?
4 of them.
4 of them? Gotcha.
Thank you.
Yeah, man. Happy to do it.
You too.
What's up, Lacey? I mean, like, it's, I'll say this, if you're trying, whatever you're doing, try to go easy. What's up, Scott? What is it? No way. No way. That might be. Oh, I cannot believe it. Right. And on a Friday, too. Yeah, I mean, like, there's a lot of good. What's up, man?
I don't think that was there. Hey, thanks for talking to me during this time. My pleasure, friend. It was my pleasure. I think this really actually believe, like, when I said that Cormac McCarthy stole all of his allegiance from Indiana, she was like, she's like arguing with me over it. I was like, this is cool. Like, I'm not being serious. She's like, when I read about the great stories in comics.
Just can't tell that like the whole schedule.
Yeah. What did she see? What did that talk about?
I was on the Wikipedia.
Yeah.
Come on,
And then she came back again. I was like,
I'm from the military. I'm good with it.
Yeah, actually.
Whoa.
She did really.
Yeah.
There was a botulism argument.
Are you losing Paris? What? Are you losing Paris?
Yeah.
He was.
We asked you if he was okay.
Yeah, it is.
Wow.
I think. Yeah. What is that?
I can't wait till
Fundamental theorem of calculus.
Number 2.
the second one.
Yeah. I really like the second one.
It's actually more fundamental.
Second one, man, opens up like the universe.
Ooh, there's T's.
What about
we did the first thing, and then we got like a bunch of time, and then more time, and I was like, okay, now we did this.
That's true. We did practice like areas or there's stuff to do, and now we've done like a new thing.
Welcome to the big leagues.
Yeah.
Hey, P, man,
We said it
have I spoiled you? I've given you all this practice time?
How do you pronounce RIEMIN?
I think it was like